today we'll be talking about building custom models in Azure AI Studio. We'll also talk about Azure AI Studio if you all are not aware with what it is. It has been revamped with the new Azure AI Intelligence Services. Before that, a little bit about myself. My name is Madhur Agrawal. I recently graduated from MIET. I am 6 years Azure certified. I recently passed my AI Engineer Associate Certified certification. I am an upcoming analyst at Deloitte India and also an Azure developer lead from Meerut. So let's delve right into the session. Okay, let's talk about Azure AI Studio first. So what is Azure AI Studio? Azure AI Studio is a web portal that brings together multiple Azure AI related services. What do you say AI related services? Those can be OpenAI models, OpenAI ChatGPT models. Those can also be document intelligence services. Then all the AI services that you can get, including bringing your own custom models with your own training data, on validation data, on performance checks and metrics evaluation. That is all you can get on the Azure AI Studio. So the model catalog and the prompt flow development capabilities of Azure machine learning service is also there. The Azure, or I would say Microsoft, has recently collaborated with OpenAI to get their custom models, that is GPT 3.54, also the 3, and all the foundational models that are available on the Azure AI portal. The next thing is the generative AI model deployment and testing, and also bringing custom data and all the integration capabilities that you can have. If you have a base machine learning model, or if you have some data that you want to train and get superb results on your production environment, or maybe your project or your application, Azure AI Studio is a go-to thing. The next thing is integration with Azure AI services for speech, vision, language, document intelligence, and content safety. So, what are these? Let us talk about speech first. All these speech related services, that is speech to text or text to speech, that may be required in your application are provided in the Azure AI Studio. Vision services are also there, which are for tagging images or maybe analyzing image data for custom metrics and custom results. The next thing is language services. Language services are also there if you need a translation API or maybe some other kind of API that is present in the Azure AI Studio. Then it is also available for you. Okay. The next thing we'll talk about is Azure Document Intelligence. Document Intelligence is one of my favorite features, which provides a service which lets you analyze your documents. Let us say you have an hospital. You have a hospital which generates a lot of PPI invoices, like for let's say the doctor's prescription it generates. So document intelligence services can analyze those prescriptions, maybe get that into a JSON format for your analyze and custom metrics, and that can also be provided by the AI Studio. Then we also have content safety. Content safety is one of the pillars for the responsible AI. That is a separate topic and also a separate dashboard. Okay, now let's talk about this is the Azure AI Studio portal. So as you can see here, there is some options like model catalog, model benchmarks, Azure OpenAI, AI services, and a lot more. You can also explore cutting edge models or start using Azure OpenAI. As I recently said, that Azure has collaborated with OpenAI for getting its foundational as well as all the recent models that it has launched. The GPT has recently launched 4.0 model that you can also get in the Azure AI Studio and it can integrate in your application or business. So this is how the Azure AI Studio portal looks like. Okay, so now let us talk about developing a language model apps in the Azure AI Studio. So in this particular session, we are talking about training your custom models that you can bring into the Azure AI Studio. So training works in two ways. One that you might have is the getting a foundational model from the Azure portal itself. For example, the GPT 3.5 model. On that model, you can train your data or get some custom results and also can integrate in your application. The second thing you can do is bring your own custom models, tweak some parameters. For example, I would say the accuracy, accuracy measurement parameter, or maybe the precision measurement parameter. That all you can do in Azure AI Studio. So let us talk about developing a language model apps in the Azure AI Studio. Okay. So the core components of a custom language model apps include these three things, that are inputs, nodes, and outputs. So input, as you can already guess, it is the input that we can give to our model app. The second thing is the nodes, which represent all the tools that are required to perform that data processing or the task that is given to the model. For example, let's say I have a app which can translate a doctor's prescription from English to French. That can be done by this custom language model app. So the third thing is outputs, which can represent the data produced by the flow. The flow, what you say. So let us see in the next slide. That is the model pipeline. So basically, this model pipeline shows you three steps. The first step is the inputs that is produced, that is given to the model or the flow. The second step is the pre-processing or the processing and the inferencing task from the model. Let us say I use a GPT-3 model for that particular task. Then the input I gave is the English prescription produced by the English doctor. Then the second, basically the second thing is it is gonna break the prescription into some tokens that are going to be processed by the GPT model. So that is that. So the in the second step, it will produce that output like by processing the English prescription into the French language. And in the third step, I would say, in the third step, it would produce the output that is the French prescription script for the doctor. Okay, so let us talk about the tools that are available in the prompt flow. Basically, these are the three types of tools. That is the LLM tool, Python tool, and the prompt tool. What an LLM tool does, so it enables custom prompt creation utilizing large language models. So basically, whatever prompt, that is the command that you give to a large language model, there is an LLM for that also. So basically, for an LLM, you are creating an LLM so that it can provide a custom type of prompt. So the second thing is the Python tool, which helps in the execution of custom Python scripts. Let us say if you have some script that is for maybe tokenizing or maybe breaking it into multiple parts, that can also be done in the Azure AI Studio with the help of prompt flow and the tools available with us. The third thing is the prompt tool. It prepares prompt as a string for complex scenarios or integration with other tools. So basically, when this one was a very simple example of producing the French prescription from an English prescription. But there may be some scenarios where you could have a complex task or maybe some complex thing that you have to do. Prompt tool will help you in preparing a prompt in the string format for those complex scenarios. Okay, now let us talk about the types of flows in the prompt flow. So the first type of flow in the prompt flow is the standard flow, which is ideal for general LLM based applications and development. It offers a versatile dictionary of tools. Also, it is very easier to use comparative to other type of flows. The second flow is the chat flow, which is designed for conversational applications with enhanced support for chat related functionalities. Let us say if you have an application which is based on Azure. Let us say if I have an online shopping based application and you need a chatbot for the integration, then you can use a chat flow to develop a custom language chat app. Let us say I am an Indian and sitting in the India while your shopping application is based out of Poland. So it might require that language translation or maybe that language, different type of language, pre-processing that is required for your model. So Promptflow has a tool known as Chatflow, which you can integrate with your application so that you can design a versatile chat-based application. The third flow is evaluation flow. That is focused for performance evaluation. For example, let's say if you are training a custom model, that is this session is all about. So you can focus on different performance evaluation matrices, also such as accuracy, precision, or maybe the learning rate, or whatever matrix that you use, allowing the analysis and improvement of models. So the way the model works is you have to improve it by iteration, or maybe I would say by epochs. So that can be easily acquired by the help of evaluation flow that can help you perform evaluation checks, also evaluation analysis, so that you can know where your model is lacking. Okay, so let us talk about how you can deploy this flow to an endpoint. So as you know, if you are deploying your application for a large user base, you will need an endpoint to access it, also for your applications. So that is it. So when you are satisfied with your performance of the flow, you can choose it to deploy on an online endpoint. Then online endpoint, you can send the data in the JSON format or maybe whichever format you prefer that is available within Azure. You can perform the inference over that particular data. Okay. So the endpoints are those URLs which you can integrate in your application, and you can make an API call on that. Uh, as you know that most of the services that are there in an application, especially in a like microservices architecture, you use an API based interface. So when you deploy your flow to an online endpoint, prompt flow generates a URL and a key. The key will be required to gain the access of that online endpoint, and so that you can safely integrate your flow so that no one can access it without permission. These keys are private, which can be stored in the key vaults within Azure. Also, flow is a run and output is returned in the real time. Let's say if you have deployed your application in some region, then you can also integrate that online endpoint in that particular region itself so that it can retrieve the data in real time. So basically this is what deploying the flow to an endpoint is. So the next thing we are going to talk about is monitoring evaluation matrices. Monitoring evaluation metrics. So basically the key metrics that are used for the evaluation in a prompt flow. Basically it allows some insights of how the LLM that we have is performing. So these are some of the metrics. Basically it is groundedness, relevance, coherence, fluency, and similarity. So the groundedness measures the alignment of an LLM's application output within the input source or database. The next thing we have is the relevance that assesses how pertinent the LLM's application output is to the given input. The coherence evaluates the logical flow and readability of the LLM application's text. The fluency assesses the grammatical and linguistic accuracy of the LLM's application output. Then the next thing is similarity, that quantifies the contextual and semantic match between the LLM's application output and the ground truth. So these are some of the evaluation metrics that basically determines how your LLM is performing. Because as you know, like the fluency is very much necessary, that the LLMs needs to be grammatically correct, the syntax needs to be correct. Also linguistically, it needs to offer the perfect language that it has. As we talked about, that you are integrating the prompt flow into your application for the language basics. So basically if you are developing a chat based application, so that needs prompt flow, so it needs to be linguistically correct. Also the similarity is also needed so that it can evaluate the ground truth level. Let us say the sun rises from the east and sets in the west, that is the ground truth. So basically similarity matrix compares what is the ground truth and the output that is produced by LLM, so that it can know where it is lacking. Let us say the LLM produces the output of the sun rises from the west and sets in the east. So that is totally different from the ground level and totally bad for our application. So these are some of the evaluation metrics. Basically, if you are deploying a prompt flow application, they are much needed so that you can integrate a better LLM into your application. The next thing that we are going to talk about is building a RAG-based Copilot solution with your own data using Azure AI Studio, which is a part of bringing your own custom models to the Azure AI Studio. Basically, when you are using RAG, that is retrieval augmented generation, so you can do that with the help of Azure AI Studio, which provides a platform with the custom Copilots. The Copilot that you are well aware of, such as GPTs, OpenAI's models, that is that. So let us talk about RAG first. RAG is a technique that you can use to ground a language model. In other words, it's a process for retrieving information that is relevant to the user's initial prompt. In general terms, the RAG pattern incorporates the following steps, such as the first step is retrieving ground data based on the initial user entered prompt. Then the second thing is augmented the prompt with ground data, and then using a language model to create a grounded response. So basically, this is the basics of RAG, that how the LLM produces basically an output against an input. So basically, user entered prompt is grounded based on the initial prompt. Then the prompt is augmented, and then the language model generates a grounded response. Okay. The next thing is adding grounded data to an Azure AI project. So you can use the Azure AI Studio to build a custom copilot that uses your own data to ground prompts. You can bring your own data on that you can upload using your local computer or maybe the Azure Blob Storage. Okay, so Azure AI Studio supports a range of data connections. So basically, it is Azure Blob Storage, Azure Data Lake Storage Gen 2, and Microsoft OneLake. So basically, these are three options that are available, and you can also upload files and folders to the storage by used by your AI Studio project. So that you can do so that you can bring your own grounded data for Azure AI project and basically train your own RAG model. Okay, so the next thing is basically this is the interface that I would like you to see. So as you can see here, you can add your own data, upload from your files and folder, or maybe make a new connection. Okay, so basically you can make a connection that is from as we see in the previous slide, that is Azure Blob Storage, Data Lake, and OneLake. So basically these three types of connections are available. Then you can, after adding your own grounding data, you can add it to your RAG model. Okay. So the next thing that we are going to talk about is using a vector index. If you are I would say like familiar with the AI concepts, then you must know a vector database or vector indexing database. So vector index is used so that it can easily generate your responses or make the responses generate faster. If we do not have a vector index, then the responses might get delayed, or it might take a long time for the generation. So as we can see in this particular vector index, the children is vectored towards kids, the parks is vectored towards playground, and the happily joyfully is vectored towards happily. These all six words are in a common vector index that because of the children, park, and happiness is bound together. If the children goes to the park, they are happy. That is a natural thing. So these are stored in a vector index. As we can see in the document 1, the children played joyfully in the park, and in the document 2, kids happily ran around the playground. So basically from these two documents, it created this particular vector index database. It created in a Euclidean vector space, that is the core mathematic of ML math. So it in the like Euclidean vector space, it created these vectors, that is the data points that are children, park, and joyfully, and vector towards that children is similar to kids. So it binded together with the help of a vector. Then park is similar to playground, it also binded together. Then joyfully is happily is also binded together, and they are stored in a common vector database because they are like very closely related. Okay, the next thing let us talk about is creating a search index. So in Azure AI search, a search index describes how your content is organized to make it searchable. As you might know that making your content organized, or making your data, or making your indexes organized, it helps in faster searches and lower search complexity. So let us see by an example that Microsoft proposes. Imagining a library containing many books, you want to be able to search through the library and retrieve the relevant book easily and efficiently. So to make the library searchable, you create a catalog that contains any relevant data about books to make any book easy to find. A library's catalog, it serves as a search index. So basically what we are talking about, that if you have a college or maybe a public library, the books are indexed according to their names, that is a particular alphabetical order. They are also indexed by the genre, that is fiction or maybe non-fiction or maybe health related or maybe whatever the different topics are. So it helps in easier indexing, it helps in making searching faster. If all the books are scattered throughout, that will make it definitely a lot, I would say, like difficult for searching that particular book that you need to search. So therefore a search index is really necessary to maintain for especially when you are bringing your own model that cannot perform search indexing by themselves. So Microsoft AI Studio basically also provides you a platform to create a search index. So this is the how the portal looks like. Basically, you can produce your own source data, then index your storage, and then here you can see add vector search to this search source. This is the toggle that you can turn on and off. So basically, that is how you create a search index when you bring your own custom data. Okay, so let us see a sample creating a chat flow with Azure AI Studio. That is what we have seen with the help of prompt flow and all the tools that are available with the AI Studio itself. That can help you build a custom model that you need to bring to your application. Okay, so as we can see in this particular flow chart, that is the inputs, then modify query with history, then it does lookup, then it does generating prompt context, then it does prompt variants, then it chat with context, and then produces output. So basically it is an example of developing a chat flow that is with the help of prompt flow by bringing your own data. After you bring your own data, it whenever a user gives inputs, let us see, I give input of why the color of the apple is red. So basically it modify query with the history, that is the search index that you have created of whatever the closest result that it can find. It then does lookup with the help of that search index, then it generate prompt context, the context around it. The it might I might be talking about apple's iPhone, or maybe I would be talking about the apple fruit. So it develops a generate prompt context with the help of a Python thing. Then we have prompt variants, and then with the chat is generated with the context with the help of prompt variants. The output is given to the user itself. So basically, the steps are appending the history to the chat input to define a prompt in the form of a contextualized form of a question. It then looks up for relevant information from your data using the search index. Then it generates the prompt context by using the retrieved data from the index to augment the question. The augmentation is necessary so that the model performs better. The accuracy of the model can be greatly improved. Also, it is necessary so that it helps it not hallucinate. Hallucination is another concept in LLM which makes the performance of a model very low. So this is the thing that is needed, which can be improved with the help of contextualization. So the next thing is that it generates the prompt context by using the retrieved data from the index to augment the question. Then it augments the question, then creating prompt variants by adding a system message and structuring the chat history. The chat history, as you might very well be aware, the Bing Copilot also has this chat history which it can look up for creating the necessary maybe index or maybe necessary information that it might need for the result that it might bring for the next prompt. The next thing is it submits the prompt to the language model and it generates a natural language response. As you know, the large language models are capable of generating natural language response. So that is the basically the chat flow of how you deploy and develop a chat application and how that works in the background in the Azure AI Studio. The next thing that we are going to talk about is deploying a custom large language model in Azure AI Studio. So custom large language model are much needed, as you are very well aware that this is the session regarding the deploying a custom LLM in the AI Studio. So yeah, so this is the first thing that we are going to do. Basically, you have to get the model ID. You can do that by going into the AI Studio. You can also choose the model from the model catalog, and basically in the deployments option filter, you can select the serverless API. Then you have to select the model and copy the model ID in the form of the Azure ML colon // registry / Azure ML cohere /model whatever the model's name is. So the next thing that we are going to do is install the ML SDK of Azure in our local system that is using the pip install Azure AI ML and Azure Identity. Identity is needed so that it can basically authenticate with your endpoint so that it can generate the response. Here we are deploying the serverless API model. It works serverless, so basically you are not going to charge for the infrastructure cost. So basically you are going to pay for what you are using. Deploying the serverless API model, you can define the client and basically in the client you have to give your subscription name, your resource groups, and your project so that you can be built accordingly. The next thing is the model ID is stored in the local variable. Then the subscription name, basically it authenticates with the client that you have a valid subscription. Then we have creating a serverless endpoint. So the endpoint name is, here we are using a Meta Llama chat cohete. So basically this serverless endpoint is deployed and you can get the serverless API endpoint and the keys by the help of keys. Then now as you can see here we are deploying the inferencing the deployment. As we know, the model has been deployed and we can get the API endpoint and the keys. Now with the help of that API and the key that we have provided, we can inference it. So basically we are providing this input where the question is, where do I live, what is my name, which name is also used to describe the Amazon rainforest in English. So the context we have given is all the context that you can see in the window. The inference is done with the help of this data is provided in the JSON format. The JSON format is sent to the endpoint with the key that is provided. So it generates the response and prints the response. You can also develop it into your application, or maybe use a Flask server so that you can develop it locally, or deploy it locally. Okay, so the next thing that we are going to talk about is composing custom models. That is also an important topic. Uh, a composed model is created by taking a collection of custom models and assigning them to a single model ID. So what you are doing here is you are taking four different, or let's say four different or five different models, composing them into singular one so that it can produce better or maybe a wider range of outputs. In the Microsoft Azure AI Studio, you can assign up to 200 trained custom models to a single composed model ID. Okay, so basically you can integrate 200 models consecutively to your one single model, so that you can deploy it on an endpoint and use it in your production environment or an application. So let's say when a document is submitted to the compose model, the service perform a classification step to decide which custom model accurately represents the form presented for the analysis. The same thing, if I provide this question that why the apple is red, then those 200 custom pre-trained models, the what the service does is it performs a classification step of whatever the perfect accuracy that it is getting from different type of models. Like let's say I have deployed five models as a compose model. The service will check if which of the best five models has deployed output the best response. So for example, your compose model might include custom models trained to analyze your supply equipment, furniture purchase orders. Instead of manually trying to select the appropriate model, you can use the compose model to determine the appropriate custom model. Each model is trained differently for different I would say like use cases. So this is where the compose model can be the best thing to apply in your production database. In the example itself, if you are having a furniture business and you are generating invoices and you are having trouble tagging the supply equipment and purchase appropriate model and all these things, then you can use the compose model so that it can determine it can select the appropriate model for your from your document. Now the next thing I would like to talk about is custom for if you have a custom basically document processing tasks workflows or maybe tasks that are integrated in your applications. Okay, so basically this is an architecture that you can see on your screen. So basically from the source, that is the email, that might be an email server or FTP or web apps, the data ingestion and orchestration works. Then the data is stored to a blob storage or maybe lake storage, and then labeling, tagging and training does from the recognizer studio, language studio and ML studio. Then built-in deployment is done from in the form of form recognizer, in the form of cognitive service for languages, in the form of Kubernetes or maybe batch online managed endpoints. So basically what we are doing is we are taking the source data, then we are basically making it into our systems and orchestrating pre-processing the data. Let us say we have PDFs, then we are pre-processing these PDFs, then we are storing these PDFs in the one of the available options for storage, that is the blob and the lake storage. Then the labeling, tagging and training is also an important task of getting those documents that can be done by the three services available in the AI studio. One of the services are form recognizer studio, the second service is the language studio, and the third thing is ML studio. So basically then it is deployed with the help of form recognizer and the cognitive services of Azure ML. Okay, now the next thing that we are going to talk about is customizing a model with fine tuning. So if you are bringing your own model, the fine tuning is also necessary so that it can perform better. It can perform with the desired accuracy and desired precision. Okay, so let us talk about the benefits. As I said, so basically higher quality results that you can obtain from fine tuning a model, okay, just by doing prompt engineering. The ability to train on more examples that can fit into a model's max request context limit. It can also help in saving you some tokens that due to shorter prompts, which can help you ultimately save up your bills. Then the next thing is also lower latency requests, particularly when using smaller models. So basically, when it reduces the prompt and maybe reduces the some parameters, it also helps in achieving the lower latency. So this is basically the workflow of Open AI Studio. So basically, you prepare your training and validation data. That is done totally on your side when you are using AI Studio. Then use the create custom model visual in the Azure Open AI Studio to train your custom model. That we are gonna see in the next slide. So basically, what steps you have to do is selecting a base model, choosing your training data, then choose your validation data. That is optional, but in my opinion, you should do it. Then optionally, you can also configure advanced options for your fine-tune job. Also review your choices and train your new custom model. Okay, then you can check the custom fine-tuned model and deploy it for at an endpoint so that you can integrate in the form of API request. Then definitely you can use it, and you can also analyze your custom model for performance and fit in your like database. So this is what the Azure AI Studio looks like. So in the models option, you have to select the create a custom model option. Basically, these are some of the models that are like available. So basically, we are going to choose a create a custom model option. Then basically, this is the wizard that comes forward. You have to select a base model that is present in the Azure AI Studio. After selecting your base model, you have to upload your training data. That you have to choose either the data set that you have provided in the ML Studio or Azure AI Studio, or you can like upload it from your local system. Also, the Azure Blob Storage or Azure Data Lake is also there if you are like uploading your training data, which might be in the terabytes. So if your training data is already uploaded to the service, select choose dataset. So as I said, if you have already prepared a dataset in the Azure ML Studio or AI Studio, you can choose that service. Basically, if you are uploading a new training data, you can select from the local file, or maybe Azure Blob, or other web locations is also supported from the for like importing training data in Azure. So the next thing that we are going to do is like uploading our training data from the Azure Blob. After uploading your training data, you have to select your validation data and validation file. So validation data also stays the same, that either you can either use the same data set that you have in the AI Studio or ML Studio, or you can also like upload it from your local file. Also, you can use Azure Blob Storage. The next thing is there are some of the advanced options that you have to like select. That is the number of epochs, that is the iteration that your model has to like do for training or fine tuning your data. You can either just choose default, that is default in Azure AI Studio, or use a custom metric. The next thing is batch size, how your data set is like fitted into the model. That is the batch size, that is either 32, 64, or maybe 16 if your model is a little smaller. That you can also toggle between default and custom. The default is 32, and then in the custom you can choose your custom batch size. Then the learning rate multiplier, if you are like what type of learning rate are you using, that is the default is 0.01 in for the base models. You can also use custom learning rate multiplier. Then the next thing is seed. Seed is also random. Also, you can like put in a custom seed that can produce a consistent result towards your model. Okay, so the next thing that you can do in your custom model is basically review all your choices. The base model we have selected is GPT-35 Turbo. Basically, training file is also training set.jsonl, that is JSON limited format. The validation file is also validation set JSONL format. The number of epochs we have like a custom metric, that is 2. Then we can start the training job. After that training job, basically you can use the model pane. So what model pane do is basically it checks the status of fine tuning job. Basically, it is a portal after you start your model training with the help of custom parameters. Basically, you can check of how what is the progress of your model training or fine tuning. Or in the model name column, select the model name to view more information about your custom model. You can see status, training results, training events, and hyperparameters used in the job. The hyperparameters we had configured in the in the recent task, as you can see here. Basically, these are known as the hyperparameters, that is the epochs and batch size or learning rate and seed. These basically advanced options are known as hyperparameters that you can toggle based on your application or task, or maybe whatever performance metric that you need. Basically, then you can select the download training file option to download your training data that you use for your model. Basically, if your data is in the Azure Lake or maybe Azure Blob Storage, then you can use that download training file option. Also, you can select download results to download the result file attached to your fine-tuning job for your model and analyze your custom model for training and validation performance. So basically, these two types of checks that you can do is on the training and validation data. There are three types of checks that you can perform. That is on the train data, validation data, and test data. So the training and validation performance can also be checked in the model pane option in the Azure AI Studio when you bring your own custom model. Okay. So deploying the custom model is also very similar to how we deployed a custom endpoint. Whenever the model training is completed from the side of from our side, so basically what it does is you can see the status. When it is under training, it will show under process or under training. When the status of the fine tuning job is completed, it will show as succeeded. So you can select your model. So we created this model known as GPT-35 Turbo 0613. So what we can do is we can select it using the deploy option, basically in the model pane. So the next thing is, let us see. So yeah, whenever you see this deploy model option, so what you can do is select your model that you have recently trained. You can also select a deployment name. Basically, if you are deploying it to an endpoint or maybe using an application, like basically application endpoint from your application, or as an API. So this is how you deploy your custom model. These are some of the fine tuning steps. I would like to first of all, let us see. These are some of the fine tuning steps, that is bringing on our base model. Then you have to bring your own training data. Also, validation data is also needed. That is optional, but you can also bring your validation data to check performance matrices, basically metrics. Then you can tune up these hyperparameters of epochs and batch size and learning rate and seed. So that is how you fine tune a model and basically deploy it. And then using that deployment, you can deploy it to the endpoint. After you create an endpoint, you can integrate it into an application. So yeah, these are some of the steps that are needed for your deploying your custom model in Azure AI Studio. You can develop it as a language flow model. If you have a language based application, you can use the document intelligence service if you have a document specific model, or totally you can use a custom base LLM and use your fine tune parameters and bring your own training data so that you can create your own custom model. So Azure AI Studio is one of the best services if you are looking forward to integrate in your application an LLM, which is which is a need of this hour in the AI revolution. So I would say go ahead and use the AI Azure AI Studio, create your own custom model, basically fine tune it, tune in the hyperparameters. You can also save some checkpoints. That is if your model basically uses 3 or 4 checkpoints, you can use those 3 or 4 checkpoints to save those so that you can continue the training process or maybe analyze the performance matrices. That is it for my session. I guess this is one of the survey links that you can scan and give your survey for the season of AI. That is for my session. Basically, you can pause the slide and scan this QR code. So thank you. The content courtesy is totally from Microsoft Learn. It is an awesome platform if you would like to upskill your Microsoft or Azure journey. So that is where I trained for my Azure AI Engineer Associate certification. That is where I passed my 6 certifications of Azure. So it is a great platform. Go ahead and check it out. Train your models in Azure AI Studio. Use MLflow and all Azure cognitive services. And also you can go ahead and check out responsible AI dashboard. That is one of the important things when you talk about content safety and regulations that are much needed when you basically comply in a particular country's services. So yeah, guys, thank you so much for coming.